Hello and welcome back to UniWest YouTube channel. In this video we will explore the EVI's ECS-5 auto calibration script. Here are the accessories we will use. The ECS-5 smart scanner. We have an SSB-500 probe, half-inch diameter probe, 27 pin to 27 pin Fisher cable, and an aluminum reference standard. So this is part number VM30889-C1A. And then we also have the holder for the ECS-5 reference standard. Okay, let's go ahead and get started. First thing we'll do is connect the ECS-5 scanner to the cable. And the other end of the cable we're going to connect to the probe connector on the top of the instrument. The instrument will auto-recognize that we have an ECS-5 scanner connected. And at this point it will load in the appropriate initial settings for the scanner. So once this is all done, then we could actually manually go through the process of setting up the gain and rotation and liftoff and whatnot. But we're going to actually use the auto calibration script that's built into the instrument. So if the main menu isn't shown, we're going to press F4. So that's going to show the main menu. And we're going to scroll down until we see auto calibrate / run script and hit enter. And then hit enter one more time. And on this list, we're going to scroll down until we get to ECS-5 multi-material. And we're going to press enter. So now it's asking us which standard do we have? Do we have an Air Force standard or a Navy standard? So in this case, we have an aluminum Navy standard. So aluminum is Navy, steel is Navy, tie is Navy. Even though we just have the aluminum, we don't have the steel reference standard and the titanium reference standard, but we'll get back to that in just a second. So we're going to go ahead and hit enter. Now we have to choose the frequency for the different materials. So for aluminum, we're going to keep it at 500 kilohertz, but we could choose aluminum off, aluminum 200 kilohertz, aluminum 500 kilohertz. So we'll keep it at 500 kilohertz. Steel, we're going to have it, the frequency is off. Titanium, the frequency is off. And we're going to press the enter button to accept and move on. So the next thing that we need to do is choose what is the diameter of our probe. So we have different selections down here across the bottom. So we're going to choose F3, which is going to give us 0.438 to 0.750 inch diameter. Choose that. Now the next on screen says the scanner is moving the probe mount out of the scanner. Alright, so the next on-screen instruction is telling us to apply the Teflon tape to the probe, which we already have some on here, and insert the probe into the scanner. Alright, probe is inserted. F1 to continue. Place the scanner on the top with the probe along the edge so we can set the lift off. So just hold on to it. Continue. Alright, so we've got the lift off. Next thing we need to do is align the probe split so that it goes along the long edge of the scanner. And then we're going to place it into the appropriately sized hole, in this case the half-inch diameter hole. And hit continue, F1 to continue. So it'll go through this auto calibration process. It'll take approximately 1 minute, and we'll get status updates here in the upper left-hand corner in some fine print. Processing data, please wait. Okay, there's the calibration response over the notch. Notches. And the aluminum is calibrated. So during the calibration scanning step, the scanner will continue to try and calibrate up to 5 times during the process. If it can't detect the notches correctly, it'll fail the calibration. You'll get a note up here that says calibration failed. In that case, hit cancel and restart the script file. So now we're ready to scan the hole, but first let's hide the menu so we don't have all of that on the screen. So we'll hit F4 to hide the menu, and now we're ready to Okay, so it's done scanning the hole. This reference standard has 3 layers of aluminum, so there's 2 interface lines down here, and you can see those 2 interface lines indicated by the yellow. So the first interface is between layer 1 and layer 2, and then the second interface line is between layer 2 and layer 3. Then also what we're seeing, the red is the EDM notch at the very top, EDM notch at the bottom of the first layer, and then there's a through notch in the 3rd layer, and we see that on the screen. So now if we want to save this setup for later, so when we come back we don't have to go through the auto calibration process, we can do that. So let's go show the menu, and we're going to go up 1 level and go to File, hit Enter, and we're going to come down to Save, hit Enter, and now we're ready to name it. So we can name it with using the scroll bar to select the different letters, a bit of a tedious process, or we can use an attached keyboard. So in this case I have the USB dongle wirelessly connected to the keyboard, or you could use a wired USB. So I'm just going to name this ECS-5. Get rid of that leading D. So ECS-5, and we'll go _ AL _ Navy, and then we'll go Enter to save that. So we're saving that setup file into internal memory, and now when we come back in an hour or a day or a week or whatever, and we have this same scanner, this same probe, and this same reference standard, we can just come down to Load, Enter, find that ECS-5 AL Navy file that we just created, hit Enter. Yes, I want to load that file. So it's loading that setup information into memory. And now we're ready to go again if we wanted to scan. All right, that's it. That concludes today's video. Thank you for watching.